Hello students, in the previous class we discussed what is aerobic and anaerobic composting and design criteria. Today let us understand the different methods of composting. There are various methods of composting, that is Bangalore method, which is anaerobic composting, indoor method, which is aerobic, then Windrow composting, Wormy composting. The first organized composting is reported from India in 1930 by Howard Acharya Subramaniam, known as indoor process. So indoor process was the first developed in India in 1930. Indoor is a place name. Now let us understand Bangalore method, that is an anaerobic method. So anaerobic, as you all know, that is in the absence of oxygen. So this is carried out in a pit and the composting material is not turned or mixed, so only we call it as anaerobic. Then it is allowed to remain in the pit for 4 to 6 months. So how it is done? So here you can see in the figure there is a pit, and in that pit alternate layers of refuse and night soil. Refuse, night soil you can see. So let us understand how it is done. So initially a layer of coarse municipal solid waste is placed at the bottom of the pit to a depth of about 15 to 25 centimeter and is made 7.5 centimeter thick for 25 centimeter width towards both the edges of the pit. So starting you have to do lining of the pit. Then the night soil, that is the waste, excretal waste, that is night soil, is put into the depressed portion to a thickness of about 5 centimeters. So there is an alternate layer of 15 centimeter refuse and 5 centimeter night soil, and the elevated edges to prevent it from draining to the side. A layer of solid waste is put on the top of the night soil layer, is sandwiched between the two layers of municipal solid waste. So here in the figure you can see a night soil layer is sandwiched between two refuse, that is municipal solid waste layers. Then solid waste and night soil are put in alternate layers till it rises to a height of about 30 centimeter above the pit edge. Then the final layer of solid waste is at least 25 to 30 centimeter thick. Then the composting mass develops at a temperature of about 60 degrees centigrade in few days. So because there is no aeration, the temperature increases, and after decomposition the volume decreases and the pile settles to half to 2/3 of the original depth. Because it is undergoing decomposition, the material starts decreasing in the volume and it settles down to about half to 2/3 of its original depth. Then the new layer is added until the level is again above the pit. Then pit is completely filled and a final soil layer is laid to prevent fly breeding, entry of rainwater into the pit, and for conservation of released energy. Final layer of soil is given or laid to prevent fly breeding, then entry of rainwater into the pit, and conservation of the released energy. Then the material is allowed to decompose for 4 to 6 months, after which the stabilized material is taken out and used as compost. So you will get after 4 to 6 months the compost, okay, which you can use it as a fertilizer in your fields. Then let us understand what is indoor method. So indoor method is again similar to Bangalore method. It is also done in pit. So this method of composting in pit involves filling of alternate layers of similar thickness as in Bangalore method, that is around 15 centimeter refuse, that is solid waste, and 5 centimeter night soil layer. So in this method also it is the layers are laid with the similar thickness. However, to ensure aerobic conditions, because the indoor is an aerobic method wherein oxygen is used for digestion or composting, so the material is turned at a specific interval, for which a 60 centimeter strip on the longitudinal side of the pit is kept vacant. So beside you can leave some space of around 60 centimeter strip on the longitudinal side of the pit, that you have to keep vacant. Then for starting the turning operation, the first turn is manually given using long handled rakes 4 to 7 days after filling. So you have to turn the material after 4 to 7 days of filling using handled rakes. Then the second turn is given after 5 to 10 days. Then after 7 days you have to keep the material. Then after 5 to 10 days again you have to give the second turn. Further turning is normally not required, and the compost will be ready in 2 to 4 weeks. So it is like this. In the diagram you can show. Here you can see the space left after the first turn, that is around 60 centimeters space you have to leave for turning. Then a pit being filled, in that pit you have to leave some space, then emptied and it contents transferred for maturation. So small portion of it you can take out. As it undergoes maturation, you can go on taking out the material which is completely digested. So storage for maturation, you have to keep for maturation, and once the maturation is over, you can take out all the material, and the new pit for composting you will be getting empty pit for again carrying out the same process in the same pit. So this is done in indoor method, that is aerobic method of composting. Then what is the difference between Bangalore and indoor method? So the Bangalore method functions aerobically, this I told you, and indoor composting system relies on aerobic activity. Here turning is required, and in Bangalore method there is no turning. So then next one is fly breeding and odor problems are often associated with this Bangalore method. Whereas because we keep on turning the material, this method has better fly control. Then as it takes 4 to 6 months, it is a slow method, and this is very rapid method. Indoor method is rapid method. Then here you can find non-uniform decomposition, but here in indoor method you will get uniform decomposition. Then after 4 to 5 months the composting process is completed, the Bangalore method. In indoor method, during the period of active composting, the contents are turned from 1 to 5 times over a period of 16 months. Then more labor intensive method, and indoor method is less labor intensive method. Moisture control problems are often associated with Bangalore method, whereas less moisture control problems are there in indoor method. So these are the differences between Bangalore and indoor method. Then let us understand what is windrow composting. So windrow, it is done in rows, so it is called as Windrow's composting. So the organic material which is present in municipal solid waste, that can be converted into a stable mass by aerobic decomposition. So this also is an aerobic method of decomposition. So aerobic microorganisms, they oxidize organic compounds to carbon dioxide and oxides of nitrogen and carbon from the organic compounds, is used as a source of energy while nitrogen is recycled. So in this method, as it is a aerobic method, so the microorganisms, what they do, they oxidize the organic compounds which are present in the solid waste to the carbon dioxide and oxides of nitrogen and carbon from the organic compounds, is used as a source of energy. So here the carbon dioxide and the oxides of nitrogen and carbon, they are used as a source of energy while nitrogen is recycled in this method. So in areas or regions where higher ambient temperatures are available, composting in open windrows is to be preferred. So where the temperature is high, ambient means room temperature is high, there the composting is done in open windrows is to be preferred. So in this method, the refuse is delivered on a paved or unpaved open space, but leveled and well drained land in about 20 windrows, with each windrow of size 3 meter long, 2 meter width and 1.5 meter high, with a total volume not exceeding 9 meter cube. So here you have to lay the waste in rows on the paved or unpaved open space, but you have to take care that it is leveled and it is well drained land. So the size of the windrows will be 3 meter long, 2 meter width and 1.5 meter high. So the total volume should not exceed 9 meter cube. So each windrow would be turned on 6th and 11th days outside to the center to destroy the insect and larvae and to provide aeration. So here that whatever we are keeping in rows, that material is turned on 6th and 11th day outside to the center to destroy the insect and larvae which are developed during the process and to provide the aeration. So on 16th day, the windrows would be broken down and passed through manually separated rotary screens of about 25 mm square mesh to remove the oversized contrary material. So here you have to send after 16th day the windrow you have to break and you have to pass the material through rotary screens of about 25 mm square mesh to remove the oversized material. So here you can do screening. Then the screened compost is stored about 30 days in helps about 2 meter by 1.5 meter high and up to 20 meter long to ensure the stabilization before sale. Means before you selling it out, you have to again keep it for stabilization for about 30 days and then you can send it for sale. So like this, a few pictures how the windrow method is done. So there are rows, you can see rows of the solid waste which is undergoing decomposition. So here you can see the turning, how it is done with the help of a turner. The materials are turned. So this is done in windrow composting. Now the last process, what is wormy composting? So what is wormy composting? You all know that worms are very helpful. Worm is a Latin word. The worm means worms. Is a simple biotechnological process of composting in which certain species of earthworms are used to enhance the process of waste conversion and produce a better end product. So in wormy composting, this is a process of recycling organic matter into nutrient rich compost using worms. So here with the help of worms we are going to convert or recycle the organic matter, and that we are going to use it as a compost. So it is carried out generally under aerobic conditions. So wormy compost is a stable organic manure produced as a vermicast by earthworms feeding on a biological waste material. It is an efficient recycling process of animal, agriculture and industrial waste. So all type of waste can be converted into a compost with the help of wormy composting. So wormy composting is a mixture of worm cast, humus, live earthworms and their cocoons. The major constituents are essential micro and macronutrients, enzymes, vitamins, antibiotics, humic acids and growth hormones. So in vermicompost you can get all these materials. Then there are different earthworms which are used for composting of the waste. So they are called as epigeic, endogeic and aneic. So epigeic means the litter and surface dwelling species which live upon the earth surface, and the species which live within the earth, that is they are called as endogeic. So they are soil dwelling or they live in upper soil surface. And aneic is deep burrowing species, they are present very deep. So these are the examples which we'll see with pictures. So the earthworms, they are of following variety, that is the first one you can see Escherichia fortidea, and the next one is Euryadrillus, Eugenia and Perionyx excavatus. So these are the varieties of earthworms which are used for vermicomposting. So there are 3 different species which are commonly used for vermicomposting. So this vermicompost you can produce by again 2 methods. One is you can do, or you can follow the pit method, or you can do this in Windrow method also. So in pit method what is done? The pit method is commonly used for small scale production of vermicompost. So if your production is small scale, you can go for pit method. So this is followed, this follows following steps. So the construction of a pit of 3 by 2 by 1 meter size over the ground surface using brick. You have to construct the pits of size 3 by 2 by 1 meter size. Then size of the pit may vary as per the availability of raw materials. So you can construct it bigger if your raw material is more, if you can make it small if your raw material is less. So this fill of the pit with following 4 layers. You have to fill the pit with 4 layers. The first layer will be of the soil, that is a sand or a sandy soil of 5 to 6 centimeter thick layer of soil you have to give first. Then this layer helps to drain excess water from the pit. Then the second layer above the soil will be of paddy straw or other crop residues of 30 centimeter above first layer. which will be used for providing aeration to the pit. So you in the second layer will be of paddy straws or the other crop residues of 30 centimeter above the first layer. So first layer will be of 5 to 6 centimeter. Then above that a 30 centimeter second layer of paddy straw or crop residue you have to provide, which will help in aeration. Then the third layer of 15 to 30 days old dung over paddy straws layer at a thickness of a few centimeter. This helps in initiating the microbial activity. So here the third layer of 15 to 30 days old dung you have to use over the paddy straws. So this will help in initiating the microbial activities. Then the fourth final layer will be of pre-digested material of about 50 centimeter. So inoculate 1000 worms per square meter area, or in short 10 kg of earthworms in 100 kg of organic matter. So this is the ratio which is required. Then spray water on the bed and gunny bag. You have to cover the top layer with the gunny bag to maintain the 50 to 60% moisture of the pit by periodical water spraying. So here moisture content is very important. So often you have to spray the water on the bed, and you have to cover it with the gunny bag, which will retain water for longer time. Then this is done in pit method. Now let us see how it is done in Windrow's method. So this method is widely used for the large scale production. The wormy compost, if you want to produce on a larger scale, you have to practice Windrow method. So the load of organic waste in the form of bed, preferably of 10 feet length, 3 feet width and 1.5 meter height. So this will be the size of the windrow. The size of the bed may vary as per the availability of organic waste. Then after loading, the fresh bed should be covered with a jute mat or dry horticulture waste such as banana leaf and stalks. So the top layer should be covered with jute mat or dry horticulture waste. Then you have to sprinkle the water over the covered wormy bed to maintain 40% of the moisture in the bed. So always you have to sprinkle whenever you feel the moisture content is less. So moisture present can be checked by forming lumps of organic waste using hand. It should be easily form lumps. If the lump formation, if you don't observe, then you can say that the moisture content is less and you can sprinkle the water. Then the bed should be mixed thoroughly to prevent it from becoming compact. So here mixing thoroughly is very important. Then the first lot of wormy compost is ready for harvesting after 2 to 2.5 months, and the subsequent lots can be harvested after every 6 weeks of loading. So you will be getting the wormy compost ready for harvesting after 2 to 2.5 months, and the subsequent lots can be harvested after every 6 weeks of loading. Then watering the bed should be stopped for at least 2 to 3 days before harvesting. So if when you have waited for 2 to 2.5 months, so before 2 to 3 days of harvesting, you have to stop watering. The earthworms, they go down in the moist soil and the compost is collected from the top without disturbing the lower layer of wormy bed having the earthworm. So earthworm, they will go where there is in the deep, the moisture content will be more, so they go and settle at the bottom. So you can harvest the top layer without disturbing the lower layer of wormy bed where the earthworms are present. So wormy compost harvested will be of dark brown color and it will be free flowing, and the harvested compost should be stored in a dark and cold place. So this is how we do wormy compost by using Windrow method. Now let us discuss what are the benefits of wormy compost. So this helps better plant growth and crop yield. This improves the physical structure of the soil. This enriches the soil with microorganisms. This attracts the deep burrowing earthworms already present in the soil in which, and indirectly improves the fertility of soil. Then it increases the water holding capacity of soil. It enhances the germination, plant growth and crop yield. Then it improves the root growth of plants. It enriches the soil with plant hormones such as annex and gibberellins. So these are the plant hormones. Then it helps in elimination of bio waste. So these are the benefits of wormy compost. Then the last concept in the composting chapter is mechanical composting. So a mechanical composting plant is a combination of various units which perform a specific function. So here I have given you the flow chart of mechanical compost plant. So here you can see the first step is reception of raw material. Then once you receive the raw material, the separation and salvaging is done, that is removal of plastic, metals, glass, etc., and the salvaged material for recycle and disposal. So you can send the recyclable material, you can separate out, and some material you can directly send for disposal which is of no use. Then the preparation of compostable matter, size reduction, screening, etc. is done. Then that is in pre-treatment of compostable matter. Then the controlled decomposition, then maturation, and the last one is market preparation. So for all these steps you need power for handling the material. So let us understand what is mechanical composting. So mechanical composting involves mechanical reception, that is receiving of the waste, then segregation, pulverization of the refuse before they are subjected to digestion. So the mechanical composting stabilizes the solid waste only within 3 to 6 days. So this is very fast method wherein only within 3 to 6 days the compost will be ready. Then the various units of this process or operation they involve in this process they are the reception of the solid waste, that is the first step. So the refuse is received at the plant at 2 to 6 tons per vehicle, that is the storage capacity of the plant should be about 25 to 50% of the daily arrival of the refuse at the plant. So how much quantity of the waste you are receiving, that must be the size of the plant. Then the next step is segregation of the waste or segregation of the refuse. So once you receive the waste, then you have to segregate it. So the dry refuse is allowed to move along a belt, conveyor belt, wherein you can separate the ferrous matter is removed by magnetic separators. So you can use magnetic separators for removal of the magnetic material, that is ferrous materials, which will attract magnet and they will be separated out. Then other non-combustible organic matter such as paper, rags, cardboards, non-ferrous metals, etc., they are also separated out manually for recycling and reuse. So this is done in the second step, that is segregation. You are segregating the waste. Then the third step is the shredding or pulverization, or you can say grinding. So the remaining refuse which you are allowing for further process, that is now pulverized by using different equipments, like you can use hammer mill, grinders, dyno grinders, etc. So these all equipments we will learn in module 2, wherein how the processing of the solid waste is done, we can learn there in detail. Now the third step is grinding or shredding or pulverizing. Then the next is stabilization. Stabilization is carried out under controlled conditions of temperature and moisture content in mechanical digesters. So the mechanical digesters of various types such as pits or cells, windows or stacks, and vertical or horizontal cylinders or even silo type closed digesters are used for stabilization of the waste. Then so the pulverized material or pulverized refuse or broken or grinding, after grinding whatever refuse we are getting, that is finally digested under controlled conditions of temperature and moisture in a digester. So there are different types of digesters available. So the finally obtained stabilized humus can be collected, it can be dried, sieved, and sometimes it is enriched by addition of some chemical nutrients like NPK and packed, and it is sold in market as manure. That is the last step, preparation of stabilized mass for market. So the large potential markets for compost, this type of compost, is agricultural sector, or it may also be used for land reclamation and for landscaping also. So this, because this is done in very fast rate, that is within 3 to 6 days you will get the compost, because here all mechanical equipments are used for operation. So this is mechanical composting. So the closed digesters are are most hygienic and they occupy less space. So in these digesters the refuse is digested and it is converted into humus and stable mineral compounds. The stabilized brown humus is collected, then it is sieved, and then finally it is sold in market. Sometimes the stabilized mass is enriched by adding chemical nutrients like phosphorus and nitrogen to increase the stability. Then the last concept is the factors affecting the composting process. So the organisms, which type of organisms we are using in case of wormy composting, and all which worms we are using. Then for other composting process also we need microbes and microorganisms, so they play a important role in composting. Then use of culture, that is what type of culture we are using for composting, that is also important. Use of culture. So during the development of composting process, inoculum enzymes, then such type of enzymes are used. So they require forms of bacteria, actinomycetes and fungi. This we have discussed in various stages of composting. So these all are you can call it as use of culture. So they need for the decomposition of the organic waste. So they also play an important role. Then the moisture. So the moisture tends to occupy the free air space between the particles. So because of this, moisture content is very important factor. If it is very high, then anaerobic conditions may set up. Then if it is very low, then also you have to it will become dry. Okay, so you have to take care of moisture content. Then optimum moisture content is known to be between 50 to 60%, so that you have to maintain. Then the temperature. So the temperature, aerobic decomposition, and even in anaerobic decomposition, the temperature plays a very important role, as we have discussed the mesophilic, thermophilic bacteria. So here the temperature plays an important role in composting process. Then the CN ratio, that is carbon nitrogen ratio. So the organisms involved in stabilization of organic matter, they utilize about 30 parts of carbon for each part of nitrogen. So because of this, the CN ratio of 30 is most favorable for composting. So CN ratio also plays a important role. Then the last one is aeration. So it is necessary to ensure the oxygen supplies throughout the mass, and aerobic activity is maintained if you supply the proper aeration. So during decomposition, the oxygen gets depleted and has to be continuously replenished. So you have to practice aeration method. So this can be achieved either by turning of the windrows, or by supplying the compressed air you can supply, and you can increase the oxygen amount in the compost or during the composting process. So this is very, very important. So these all are the factors affecting the composting process. So with this, we have come to the end of the chapter called composting. Thank you.